It smelled like machine oil and defeat. The Japanese engineers gathered around the wreckage in a dimly lit hangar outside Yokohama, their white coats already stained with hydraulic fluid and soot. A B-29 Superfortress, forced down after engine failure during a raid on Tokyo, lay disassembled under harsh arc lights. Its massive silver panels looked impossibly large, like something stolen from a battleship rather than the sky. They had been told this was the most advanced bomber the Americans possessed, capable of flying higher than any Japanese fighter could reach. That claim seemed like arrogance to the Imperial Army's engineers. Machines this heavy should belong to ships and trains, not to the thin air above Mount Fuji. Dr. Kenji Matsumoto, a senior metallurgist from the Technical Air Arsenal in Tachikawa, adjusted his round spectacles and ran his gloved hand across one of the aluminum panels. The surface was not rough like Japanese aircraft skin, but mirror-smooth, almost liquid in its perfection. "Look at this thickness," he murmured, disbelief creeping into his voice. Around him, technicians measured and whispered. "The Americans waste metal like water," one said. They had expected crude construction and brute force, not precision that seemed to mock everything they thought they knew about aviation. Outside, rain drummed against the hangar roof. Inside, the smell of American lubricants filled the air, sweet, synthetic, nothing like the castor oil and mineral spirits Japanese engines required. It clung to their clothes and throats as they worked. They began cataloging every component with surgical precision. No bamboo reinforcements, no fabric patches. Each panel had been machined to tolerances they could barely measure. The seams were flawless, joined by thousands of flush rivets so perfectly set they felt like a single piece of metal. When Matsumoto tried to remove a panel section with standard tools, the rivet head stripped before the joint separated. "This is not ordinary aluminum," he said quietly. "Whatever alloy they're using, it's stronger than anything we produce." His assistant, Lieutenant Hideo Yamada, suggested it might be a magnesium blend. Matsumoto shook his head. Magnesium was too brittle. This was elastic, heat-resistant, impossibly light yet structurally sound. He placed a fragment under a microscope and saw crystal structures unlike any Japanese metallurgy had achieved. What unsettled them most was the abundance. The B-29 was built with an extravagance that seemed almost offensive. Redundant systems, backup generators, heated crew compartments, pressurized cabins, luxuries that Japanese aircraft designers couldn't even dream of. Every rivet, every wire, every fitting spoke of a nation that had never known scarcity. As the engineers measured, recorded, and photographed, something strange happened. The initial contempt faded. The more they touched the Superfortress, the more they understood they were not fighting an enemy, they were fighting an industrial philosophy they could never match. By midnight, the floor was littered with measurement tools, diagrams, and cold tea. Matsumoto sat back, rubbing his tired eyes, surrounded by fragments that refused to make sense. The numbers on his clipboard didn't lie. This impossibly heavy aircraft had bombed Tokyo from 30,000 feet, where Japanese fighters gasped for oxygen and fuel. Somehow, America's industrial might had defeated Japan's warrior spirit. He looked at the massive wing section gleaming under the lights and whispered, "How can we fight this?" The irony gnawed at him. Japan, the land of precision and dedication, was being overwhelmed by bombers built with such material excess they carried refrigerators for the crew. Outside, the distant rumble of more B-29s echoed over the city, the sound of empire crumbling. In that hangar, among the smell of American oil and alien metal, something shifted. The question was no longer whether they could shoot down the B-29, but whether Japan's entire approach to war had been fundamentally wrong. In 1938, when America was still at peace, a team of engineers at Boeing's Seattle plant had begun designing something audacious. The specifications from the Army Air Corps seemed almost fantastical. A bomber that could fly 5,000 miles, carry 20,000 pounds of bombs, operate at 30,000 feet, and defend itself with remote-controlled gun turrets. Most manufacturers would have politely declined. Boeing's chief engineer Edmund Allen, methodical, brilliant, and quietly confident, saw not impossibility but opportunity. At that time, American industry was undergoing a transformation. The mass production techniques pioneered by Henry Ford were being applied to aircraft manufacturing. Aluminum, once a precious metal, was being produced in enormous quantities at hydroelectric plants across the Pacific Northwest. Boeing looked at the arithmetic and saw not just abundance but revolution. The company had spent years perfecting pressurized cabin technology and high-altitude flight systems. America's vast industrial heartland was filled with rolling mills, forging plants, and precision machine shops. facilities that could turn raw aluminum into aircraft parts with astonishing speed and consistency. Allen envisioned a bomber without compromise. 4 massive Wright R-3350 engines, each producing 2,200 horsepower. A pressurized cabin so the crew could breathe easily at altitude. Remote gun turrets controlled by advanced computing sites. Redundant systems for every critical function. It would be the most complex aircraft ever built, not through cleverness but through sheer industrial capacity. When war came in December 1941, the B-29 project accelerated from ambitious to essential. Boeing's factories transformed into industrial cathedrals. Assembly lines stretched for miles. Women who had never touched tools became precision riveters. The aircraft that emerged was not elegant, it was overwhelming. On September 21, 1942, the first B-29 prototype rolled onto the runway at Boeing Field. Edmund Allen climbed into the cockpit along with his flight crew. The engines roared, 4 massive radials that shook the ground like thunder. As the aircraft lifted, observers expected struggle. Instead, it climbed steadily, its massive wings carrying 140,000 pounds into the sky as if weight meant nothing. At altitude, its pressurized cabin worked flawlessly. The crew breathed normally while outside the air was too thin for life. The remote gun turrets tracked imaginary targets with mechanical precision. Allen radioed back, "She flies like she's on rails." That night, Boeing engineers celebrated quietly, knowing they had created something unprecedented. Not the most beautiful aircraft but perhaps the most powerful. The B-29 would force Japan to confront a truth more terrifying than any bomb. America could outproduce them 100 to 1. When the B-29 first appeared over Japan in June 1944, it arrived from a direction thought impossible. Flying from bases in China and India, the superfortresses struck the steel mills of Kyushu from altitudes where Japanese fighters struggled to climb. Pilots who had fought American aircraft over the Pacific now faced something entirely new: massive, silver, untouchable. The Japanese Army Air Force scrambled every available interceptor. Veteran pilots in their Kawasaki Ki-61 Tonis and Nakajima Ki-84 Hayats climbed desperately toward the bomber formations. But climbing to 30,000 feet took time, fuel and luck. Many fighters never reached attack altitude. Those that did found their cannons ineffective against the B-29's defensive fire. Captain Saburo Sakai, one of Japan's most decorated pilots, described his first encounter. "We climbed for 30 minutes, engines screaming until frost covered our canopies. When we finally reached them, their gunners opened fire from 800 meters. I saw tracer fire from every direction. It was like attacking a flying fortress made of light. I fired once, saw my rounds sparkle against their armor, then dove away before their turrets could track me." The B-29's defensive armament was revolutionary. 12.50 caliber machine guns controlled by remote aiming systems could concentrate fire on any attacking fighter. The gunners sat in pressurized compartments, warm and breathing normally, while Japanese pilots fought cold, hypoxia, and fear. By November 1944, the Americans had captured the Mariana Islands, Saipan, Tinian, Guam, and built massive airfields within easy range of Tokyo. Now the B-29s came in hundreds, not dozens. The raids grew more frequent, more devastating. Japanese air defenses, designed for low-altitude combat, proved helpless against attackers operating from the stratosphere. On March 9, 1945, the nature of the war changed forever. 334 B-29s appeared over Tokyo at midnight, flying not at 30,000 feet, but at 7,000, low enough to carry maximum bomb loads. They dropped incendiaries by the thousands. The firestorm that followed killed over 100,000 people in a single night. For Japanese military observers, the message was clear. The Americans could bomb from unreachable heights or swoop low with impunity. Either way, Japan's air defenses were irrelevant. Dr. Matsumoto, who had examined the crashed B-29, understood the deeper horror. Each bomber represented more aluminum, more fuel, more precision manufacturing than Japan produced in a month. And the Americans had hundreds. They could lose 50 over Tokyo and replace them within weeks. Japan lost 5 fighters in the same raid and couldn't replace them at all. The psychological impact was devastating. Japanese civilians, told for years that their military was invincible, now watched silver giants fly overhead unopposed. Factory workers knew that each B-29 raid could erase months of production in minutes. Soldiers began to whisper, "How do you fight an enemy who builds faster than you can destroy?" The captured B-29 became Japan's most studied artifact. In hidden workshops around Tokyo and Nagoya, Engineers dissected every system with desperate intensity. They weren't trying to copy it, they knew that was impossible, but perhaps they could understand enough to find a weakness. Matsumoto's team focused on the engines, the massive Wright R-3350s that somehow produced reliable power at extreme altitudes. Japanese engines of equivalent size were temperamental, prone to overheating, requiring constant maintenance. These American engines ran for hundreds of hours between overhauls. The secret lay in manufacturing precision and materials. The cylinder tolerances were measured in thousandths of an inch, accuracy Japanese factories couldn't consistently achieve with wartime labor. The aluminum alloys used in the engine blocks contained trace elements Japan couldn't source: molybdenum for heat resistance, chromium for strength. Lieutenant Yamada examined the fuel system and discovered another shock. The B-29 used 100-octane aviation gasoline, fuel so refined it barely existed in Japan. Japanese fighters ran on 87-octane at best, mixed with ethanol and hope. The difference in engine performance was like comparing a racehorse to a plow animal. The electrical systems told the same story. Miles of wiring, all coded by color, all insulated with synthetic rubber Japan had never successfully produced. Backup generators, voltage regulators, circuit breakers. Redundancy layered on redundancy. A Japanese bomber might have one electrical system. The B-29 had three. When Matsumoto presented his findings to Imperial General Headquarters, the room fell silent. He placed samples on the table: perfect rivets, flawless aluminum, synthetic rubber that didn't crack in cold. "Gentlemen," he said quietly, "we are not fighting an air force. We are fighting an industrial civilization." Some officers refused to accept it. They demanded Japanese engineers build equivalent aircraft, prove that spirit could overcome material disadvantage. But the engineers knew the truth. Japan's entire aluminum production for 1944 equaled what America used to build B-29s in 2 weeks. The Nakajima Aircraft Company attempted to design a high-altitude interceptor, the Ki-87. On paper it could reach 40,000 feet. In reality, by the time it flew in prototype form, Japan no longer had fuel to test it properly or pilots trained in high-altitude combat. As they packed their analysis for the files that would soon be captured by American occupation forces, Matsumoto lingered by the dissected bomber. He ran his hand along the wing spar, seamless, elegant, impossibly strong. "They built this in a factory outside Seattle," he whispered to Yamada. "One of dozens. While we forge swords and speak of honor, they forge aircraft like farmers harvest rice, endlessly, efficiently, without ceremony." The captured B-29 remained in that Yokohama hangar until August 1945, when Japan surrendered. By then, it had taught its captors a lesson more devastating than any bomb. Wars are not won by courage alone, but by the cold arithmetic of production, resources, and industrial will. When the war ended, the B-29 had flown over 34,000 combat sorties and dropped 170,000 tons of bombs on Japan. It had delivered the atomic weapons that ended the war. In the smoking ruins of Japanese cities, American occupation forces found the meticulous reports Japanese engineers had compiled, studies filled with admiration disguised as technical analysis. Dr. Matsumoto was among those invited to tour Boeing's factories in 1947. Standing in the Seattle plant where B-29s had rolled off assembly lines every 24 hours, he finally understood what Japan had faced. Not genius, scale. The Americans had turned aircraft production into an industrial process as routine as baking bread. He turned to his American escort and asked how many engineers had designed the B-29. The American laughed. "Thousands. And thousands more built them. That's the secret. We didn't need perfection, just consistency and volume." That sentence haunted Matsumoto for the rest of his life. In post-war reports that helped shape Japan's recovery, he wrote that Japan's defeat was not military but philosophical. "We believed quality could overcome quantity. We were wrong. True strength lies in building systems that produce quality at quantity, something only industrial democracy seems capable of achieving." The lesson spread through post-war Japan. Engineers who had studied the B-29 became leaders in Japan's industrial resurrection. They applied American principles of mass production, quality control, and systems engineering to automobiles, electronics, and eventually back to aircraft. By the 1970s, Japanese manufacturers were producing some of the world's most reliable products, not through warrior spirit, but through the industrial discipline they'd learned from defeat. The B-29 itself became obsolete within a decade, replaced by jets. But its legacy endured. Modern aircraft still use aluminum alloys descended from those developed for the Superfortress. The remote gun turret systems evolved into modern fly-by-wire controls. Today, historians debate whether the B-29 was the most significant aircraft of World War II. The numbers speak for themselves. Longer range than any contemporary bomber, heavier payload, higher altitude, better defended, and produced in quantities that crushed enemy morale. When you see a B-29 in a museum today, and only 24 survive, its aluminum skin still gleams like chrome. You can almost smell the American industrial confidence it represented. The men who built it believed that engineering problems had engineering solutions, that enough resources properly organized could overcome any obstacle. For Dr. Matsumoto and the engineers who dissected that captured bomber in 1945, it represented something else. The moment Japan learned that modern war is won not in the skies, but in factories, forges, and the unglamorous machinery of industrial production. So the next time you see a B-29's photograph, massive, utilitarian, overwhelming, remember what it represented. Not just American engineering, but the triumph of industrial systems over individual heroism, of abundance over scarcity, of logistics over valor. If you believe that true strength comes from building systems that can outproduce your enemies, comment number 1 below. And if you think Japan's post-war industrial miracle grew from the lessons of defeat, leave a like and subscribe for more untold stories that remind us why even aluminum and assembly lines can change history.